Good morning, children. So welcome back to the online session of the mathematics class. We are discussing about the lesson circles. So in the circles, last video we have discussed about two important theorems. That is the theorem one will be lengths of a tangent drawn from external point to a circle are equal. That is one theorem. The previous theorem will be radius to the point of contact and then a tangent drawn from the external point. Both will be perpendicular to each other. So these two will be the theorems which are very important theorems. So they will be asking frequently any one of these two theorems definitely for 3 marks question. Okay. So practice these two theorems. Write twice and thrice. So whenever we are free, write these three theorems and practice it. Okay. So there will be a compulsory theorem out of these two. Okay. So after completing that, I had told you we have example 1 and example 2, which is in the page number 101. So we have example 1, example 2 and example 3. These three examples you should write in the classroom. Okay. So after completing that, we can write the exercise 4.1. We can go for exercise 4.1, page number 98. So in that, the first question is, how many tangents can a circle have? How many tangents can a circle have? Suppose we are having a circle. How many tangents we can have? So suppose let me take a circle. Okay. So this is circle with center O. How many tangents I can write for this circle? They didn't given the point. They didn't given the external point. They didn't given the point. Suppose I have given the point here, then I can say that there is no tangent. If they have given the point on the boundary, then I can say that I will be having one tangent. If I am having a point outside the circle, then I can say that I have two tangents. But in this question, they didn't given the point. Whether the point will be inside or on the boundary or outside the circle. They didn't given that. How many tangents can a circle have? This is a circle. How many tangents I can write for the circle? We know that circle is a combination of all the points which will be at equal distance from the fixed point. That is a fixed distance from the fixed point. That means we are having infinitely many points. Right? We have infinitely many points on the boundary. Right? So I can write for this point I can write the tangent like this. For this point I can write the tangent like this. For this point I can write the tangent like this. All are tangents only. So for each and every point, so here also I can write the tangent. Here also I can write the tangent, and here also I can write the tangent. Here also I can write the tangent, because these are all the tangents, because all the lines will intersect the circle at only one point. Right? So this is a line which intersects the line at one. Of course, these lines are intersecting, that doesn't matter. What is the definition of the tangent? A line which intersects the circle at only one point, which intersects the circle at only one point. Okay, so I will be having a point, so I can write a line like this. Sorry, this will become tangent. So I can write a line like this. This is also a tangent. So for each and every point on the boundary, we have infinitely many tangents I can write. So how many tangents can the circle have? In the sense, we have infinitely many tangents. Infinitely many tangents. Okay. So answer is infinitely many. We have infinitely many tangents. For each and every point on the boundary of a circle, we have tangents. Okay. So the second one, fill in the blanks. If in the second one we have some questions, those are questions. So a tangent to a circle intersect it in dash points. A tangent to a circle intersect it in how many points? So how many points it intersect? There is a tangent, there is a circle. We have a circle, right? We have a tangent. Sorry. Okay. We have a tangent, we have a circle, and we have a tangent. A tangent, and circle intersect it both will be intersect at what? One common point, right? One common point. The point is also called as point of contact. So in how many points? If it intersects at 2 points, then it is a secant. So tangent and a circle will intersect at how many points? Only at 1 point. So tangent to a circle intersect it in 1 point. 1 point. To intersect only 1 point. If it is intersects at only 1 point, then only it is called as a tangent. Or otherwise it is not a tangent. Remember that. The second one is a line intersecting a circle in 2 points. It is called, what is that? A line intersecting a circle in 2 points is called as a line intersecting the circle at 2 points is called as what? Secant. I had explained, right? Secant. Okay. Now, third one, a circle can have dash parallel tangents at the most. So, how many parallel tangents can a circle have at most? How many parallel tangents? A circle can have infinitely many tangents. In that, at most, how many parallel tangents can a circle have? So, I am having a circle. Okay. Suppose I will take this as one tangent. Okay. So, how many parallel tangents? If I take this as a tangent, so I will be having one more tangent here. So you can observe that these two are parallel to each other. These two are parallel to each other. If I write one more tangent like this, okay, these two tangents are not parallel because that will intersect at one point. Parallel lines will not intersect at all. They will not going to intersect at all. Okay. Wherever you can observe the distance between those two lines will be same. Okay. So that will not going to intersect. So you can say that these two tangents are parallel, but these two are not parallel. Right? So maximum I can have only 2 parallel tangents. Only 2 parallel tangents. So this is one and this is one. If I write like this, then that will not be becoming parallel, that will be intersecting lines. So a circle can have 2 parallel tangents, 2 parallel tangents at the most. So at most it can have 2 parallel tangents. So these are the 2 parallel tangents. Wherever I can write parallel tangent for that. Okay. So at most it can have only 2 parallel tangents. Okay. The common point of a tangent to a circle and the circle is called the common point of a tangent to a circle and the circle. The common point of a tangent to a circle and the circle is called as what? Point of contact. Point of contact. Point of contact. So the common point of a tangent to a circle and the circle is called as a point of contact. Okay. So this will complete the second one. So we will go for the third one. Third one is a multiple choice question. So the question is, it is a multiple choice question. They have given the options also. A tangent PQ at a point P of a circle of radius 5 cm meets a line through the center O at a point Q, so that OQ is equal to 12 cm. Length of PQ is option A 12 cm, option B is 13 cm, option C 8.5, option D square root of 119 centimeter. Okay. So, of course, this is a multiple choice question. Since we need to solve this, then only we can choose the correct answer. So, we have a circle. So, we have a circle. Okay. Center O. Then, a tangent PQ at a point P of a circle. We have a tangent PQ PQ, we have a tangent PQ at point P of radius 5 centimeter. Of radius 5 centimeter. Okay. Meet a line through the center. So this tangent will meet a line through the center. Okay. At a point Q. At a point Q. Okay. So that OQ is equal to 12 centimeter. OQ is equal to 12 centimeter. So that OQ is equal to 12 centimeter. Length of PQ. Length of PQ. We should find out this PQ. This length we should find out. That is length of the tangent we should find out. They have given that radius. They have given that OQ is equal to 12 centimeter. We should find out the length of PQ. That is length of tangent. Okay. How to find out that? It's very easy. By using the Pythagoras theorem. Why we need to use the Pythagoras theorem? Because it is a right angle triangle. Why it is a right angle triangle? Because tangent to a circle and then radius to the point of contact, both will be perpendicular to each other. That means angle between those two will become 90 degrees. So this is 90 degrees. This is triangle OPQ is a right angle triangle. If it is a right angle triangle, I can use the Pythagoras theorem. They have given the two sides. I need to find out one more side. By using the Pythagoras theorem, I can find out the other side. Right? Other side being given, I can find out that. Okay. So before that, I should find out that which is hypotenuse side. We should find out that because Pythagoras theorem states that square of hypotenuse side is equal to sum of the squares of other two sides, that is base and perpendicular. Okay. So we need to find out the hypotenuse side. So suppose I will take ABC as the right angle triangle. A, B, C. So it is right angle, right? So which is hypotenuse side? AB is the hypotenuse side, right? So this is AB is the hypotenuse side. This is the base and AC is the perpendicular, right? So we know that. So AB is the what? Hypotenuse. So that means in between those two angles should not be 90 degree. If I am having a 90 degree, then these two lines I can't be able to take it as a hypotenuse side. So connecting from the 90 degree, that we can't able to take it as a hypotenuse side. So this will be the base and this will be the perpendicular and this is the hypotenuse. Okay. So similarly, you may get confusion that whether this is a hypotenuse side or this is a hypotenuse side, right? You may get a confusion in the triangle that this will be the hypotenuse side or this will be the hypotenuse side. So to avoid that confusion in the sense, whichever the side which is related to the 90 degree, that is not a hypotenuse side. If it is a hypotenuse side, that should not be connected with the 90 degree. Okay, observe that. So this is a hypotenuse side, this is not connected with the 90 degree. So this is only connected with 90 degree. Similarly, here, so I can't able to take PQ as hypotenuse because PQ is connected with 90 degree. So which is hypotenuse? OQ is the hypotenuse. Okay, it's very easy. So we can write directly. This is a direct question from Pythagoras theorem. Pythagoras theorem for triangle POQ or OPQ. Okay, we can write square of hypotenuse side, OP is the hypotenuse side, is equal to sum of other two sides. Other two sides, PQ square plus OP square. Okay. Now OQ square, OQ they are given that 12 centimeter. That is 12 square. PQ we don't know that we need to find out right as it is. OP is 5, so it is 5 square. Clear? So we have to apply the Pythagoras theorem. Why we need to apply the Pythagoras theorem? Because it is a right angle triangle. So in that, if you want to apply the Pythagoras theorem, we should find out the hypotenuse side. Because Pythagoras theorem states that square of hypotenuse is equal to sum of the squares of other two sides. right? So how to find out the hypotenuse side? The side which is not related to the angle 90 degree, that will be the hypotenuse side. So here the OQ which is not connected with the 90 degree, because PQ is connected with 90 degree, OQ is not connected with the 90 degree. So therefore OQ will be the hypotenuse side. Therefore OQ square is equal to PQ square plus OP square. Okay. So this is OQ is given in the question, that is 12 square. PQ we should find out, we should write as it is OP. OP is 5, we have given. So substitute it. So 12 square, what is 12 square? 12 square is 144. 12 into 12. If you multiply 12 into 12, you should get 144. So write PQ square as it is, plus 5 square. 5 into 5 will become 25. Right? So 12 square is 144. 5 square is 25. So I should find out PQ. Keep the PQ here only. Send 25 to the other side. What will happen? 144. If you send 25 to the other side, it will become minus 25. So equal to PQ square. Clear? So 144 minus 25. 144 minus 25. So you can't able to subtract. You should borrow from here. So 14 minus 5 will become 9. Here I have 3. 3 minus 2 will become 1. So 1. How much? 119 is equal to PQ square. 119 is equal to PQ square, or PQ square is equal to 119. Both are same. LHS is equal to RHS, RHS is equal to LHS. You can write it reverse. That is PQ or PQ square is equal to 119. Correct? 119 is equal to PQ square, or PQ square is equal to 119. LHS is the RHS place, RHS is the LHS place. I am not transferring. Okay. If I am transferring, then sign is going to change. I am not transferring. I am writing the whole RHS part in the LHS place, LHS part in the RHS place. That's it. Okay. Now PQ square is equal to 1.9. PQ is equal to, if I send the square to the other side, it will become square root 119. So PQ is equal to 119. Square root of 119 centimeters, which is the correct one. So option D will be correct. Okay. So PQ is equal to 119. Okay. So this is about fourth question. Third question. We go for the fourth one. So the fourth question is, draw a circle. You should draw a circle. So the fourth question is, it's very simple. Draw a circle. Draw a circle. Circle of any radius, random radius. You can take any of the radius. 4 cm, 5 cm, 6 cm. It's a random. They didn't mention the radius. So you should take the circle. This circle has to be written by using the compass. Okay? So don't write the rough diagram. Write by using the compass. Take some radius 5 cm. It's enough. Okay? So you have to write the circle and two lines parallel to the given line. We should write the two lines parallel to the given line such that one is tangent and other is a secant to the circle. I should write two lines. That one will be the tangent, other will be the secant. Both will be parallel to each other. It's very easy. Write one line, tangent. Both is the tangent, right? It's touching, right? So it is a tangent. We have written one tangent. We should write one more tangent. We should write secant to the circle, which is parallel to the tangent. So use the scale and draw the parallel line. Okay. So it will intersect at two common points. So this is secant. This you have to do it by using the compass and then scale. By using the compass, you write this circle of 5 cm. Then write a tangent for that. Okay. Write the tangent for that. So you should write a secant for that circle which will be parallel to the tangent. Use the scale and write the straight line. That must be parallel. Don't write like this. These two are not parallels, because if you are keep on extending this line, both will intersect at that point. Parallel lines, you know that will not intersect at all. But if you write a line like this, that will intersect at one point, then we can't say that these two lines are parallel. These two are intersecting lines. Okay, so these two lines should not intersect at one point. Okay, then only these two lines are parallel. So this is the answer for fourth one. So this will complete the exercise 4.1. So exercise 4.1 is completed. So after that we will go for exercise 4.2. We will go for exercise 4.2. Again in 4.2 we have 3 multiple choice questions. Then we are having some 13 questions we have. Okay, so we will solve it in the next video. Okay, so if you have any doubts regarding the today's class, you can get back to me through my WhatsApp number, or otherwise you can call me. So do one thing, you have to write those 2 theorems twice and you have to practice them. Okay, it's very very important theorem. Go through that and please fill in the blanks. And then the third question, they may ask for fill in the blanks, they may ask for 1 marks. So they will be frequently asking either in 1 marks question or in MCQs part these type of questions from the circle lesson. Okay, so practice these type of lessons, these type of questions. Go through the previous year papers. If any of the questions arise from the circle, like MCQs or 1 marks question,